Ladies and gentlemen, our next exhibitor has quite literally been carrying the world for over 100 years. Of course it is. It's the world famous Cummins. It is the Big C. And to tell us about some of its latest projects and a little bit of history as well, I'm joined by Mr. Jürgen Ackermann. So Jürgen, we'll kick off with one of your latest developments, which is a range of structural diesel engines. This is the 4.5 litre that we've got in front of us today. So just tell us about this project, where it started, how it sort of came to fruition really.
Yeah, so this project started, I think, about 10 years ago.
Right.
Yeah, where Cummins put out of the drawer the plans from the structural engine, which we had for ages. We used to build tractor engines. And just with the new design tools like finite elements, that kind of stuff, we made it slimmer, smarter. And so what a structural engine makes a structural engine is the structural components.
That's it. This is, this is opposed to an engine that sits in a chassis. Obviously,
Exactly.
You've got a lot more elements to it to actually make it a part of the tractor.
Yeah, exactly. And the strategic reason why we have done this, we used to be in the agriculture market with tractors. So we supplied engines to CNH, to Massey Ferguson. Obviously, down the road, they had their own engine suppliers, and what would you do?
That's it.
You take your own engine rather than the other ones.
Yeah.
So this is a bit, sadly, we left one of our most beloved markets, that was the agriculture market.
Yeah.
And with this one, we're going to come back. And you may wonder why it's beloved. We have a lot of people within Cummins with agricultural background. So our headquarters in Midwest, it's an agriculture region, so a lot of farmers there. And yeah, in UK, in the engineering department, we also have a lot of people growing up at the farm.
That's it. I've met a lot of guys especially the Darlington facility.
Yeah.
There is a lot of people from an agricultural background. What do you think it is that draws people from an agricultural background to work for Cummins? Is it a bit of a sort of a can-do attitude?
Oh, it's the first thing is it's really the technical background. You know, when you're in agriculture, you think engines. A lot of guys they remember. Oh well, they don't remember. You still have those tractors and combines in the field with Cummins, so they know Cummins that's it.
That's it. From my point of view, I certainly remember the early Case AH Maxims, the Case MXs and the Magnums, and just having that CDC engine in there, that world famous CDC engine.
Yeah. And there was the 3.9 and the 5.9 liter engines in masses in the tractors and combines at that time. But yeah, anyway, it made us to go back to this market, and there's a lot of people being happy within Cummins that we do this.
Yeah.
Emotionally as well. It's not always balance sheets. It's a bit this thing. But yeah. So what makes a structural engine structural? It's as explained. It's a structural oil pan, the structural block, which are directly mounted to the front of the tractor, and also directly mounted here to the transmission. So at the end, the engine becomes part of the tractor.
Absolutely. It's
design,
almost the backbone of the tractor, isn't it?
It is, yeah. If you remove the engine, the tractor just falls off.
Yeah.
but yeah, so that's it. You have this structural pan, structural block, an adapter plate, obviously also carrying the structural load, transmission, front drive. And what is the first challenge? You need to understand what are the loads coming.
That's it, there's a lot of stresses.
Exactly.
In all directions.
And this is what we need to calculate and need to design the elements for. So really, the engine does not see the stress.
Yes.
So that's what is product for.
And the actual stresses through the engine, does it sort of, I don't know, is it kind of sort of carried around it, under it, sort of?
Yeah, well,
how are they sort of transferred, kind of thing?
So you have this kind of
so like a torsional
stress. You got
stress.
this, you got all the bendings in every moment, and So what it does, so from the engineering, when you look at those diagrams where all the stress goes, it goes down here nicely into the pan and just sticks at the pan.
Right.
So whatever is left and would be seen on the block, that's why we have a structure block.
I see.
Yeah.
And then obviously we've got a 4.5 litre here. Now I seem to remember the last AGRITECHNICA 4 years ago, 2019, you had a 6.7 litre version.
Yeah.
So are you going to do a whole family of structural engines? Is that sort of on the cards?
That's a very good question. So yeah, we started with the 6.7, but interestingly enough, when we were doing this, and we have a 6.7 in a tractor. It's our own tractor, and it's got used on a farm. We reckon that the customers we talk to, tractor manufacturers, are far more interested us building a 4.5 liter.
Right.
So that made us change to stop the 6.7 for the time being and start with the 4.5.
So they saw the 6.7, they liked what they saw, and they said, can you do as a 4.5? And do you do a 3, is it 3.6 as well?
A 3.8, yeah, we decided.
3.8 is it?
3.8,
Yeah.
But we will stick with the 4.5 only.
Right. Okay.
You know,
so this is the main focus at the moment in terms of development.
Exactly.
Right. And obviously we can't, it's a bit of a tricky, sensitive area, this next bit, but obviously we can't sort of go naming potential customers that have come to you guys, i.e. manufacturers that potentially want this. So in terms of when you are developing something like this, you say you've had this in development for the last 10 years, who kind of kicked that off? Is it the demand, or is it you guys aiming to show a product first?
Yeah, to be honest, we kicked it off first.
Right.
It was a bunch of guys that were always like, we need to do this. We should do this.
Yeah.
And of course it's chicken and egg. And then you go out, present it to tractor manufacturers.
Yeah, such as this. Great place to do it.
And sooner or later you get a positive response.
Yeah.
So with the response we continue developing it. So it's a bit this kind of, until you got fixed customers.
You have to have something to show them first.
Exactly. That's what it is.
That's it.
And what makes a tractor engine, the most obvious, of course, is a structural engine, the structural components. The next one is the turbocharger selection. So that's another one where this engine differentiates to other off-highway engines. So particularly for the small engines or small tractors, you have this front-end loader application, and there's a lot of torque required at the low speed. So that engine is geared towards high torque at low speed.
Okay.
And quick response time at low speed to cope with all those requirements.
And a lot of that comes from this.
Yeah, this is, with the selection of the turbocharger, you select the shape of the torque curve.
Yeah. So is it this will be a VGT on this, is it, or is it?
It is a VGT, yeah.
That's it.
Yeah.
And that'll allow you to get the ideal tuning for the ideal application, effectively.
Yeah.
Or at least it helps. It's a big part of that.
It does, but don't underestimate the wastegate. The VGT, yes. In some of our products, we also use wastegate.
Yeah.
And it's a perfect fit. Our engineers always find out what is the best fit for the application, for the customer. But yeah, in this case, it was a VGT. That's what we did. And the last portion was the aftertreatment.
Absolutely.
So, imagine this long cylinder box we have, which is a perfect fit in most of the machines. In the tractor compartment, you don't have that space. No? So we have the...
Especially on 4-cylinder tractors.
Yeah, so we got a DPF on top here. And then you got this pipe getting out, and then the SCR stocks on the outside on the tractor. So pretty much the standard.
Okay. So just talk us through your cleanup strategy in terms of emissions these days. So do you guys employ any exhaust after treatment at all? Sorry, any exhaust gas recirculation, I should say, through the engine?
Yeah, what can I say? Definitely not. No?
Definitely not now.
Yeah,
that's gone. Get out of here.
Exactly, but this is what we want to avoid.
I like it. Yeah. I like it already.
How would you say this?
So this isn't breathing its own muck.
Exactly, because to be honest, we don't want our end users to cope with cool EGR.
Yeah.
Period. Why? So first thing is, you have this cool EGR sitting there. It generates additional heat.
Yeah.
The last thing you want on a tractor, you don't want it on a combine either, is hot surface. Obviously, hot surface, you got the dust there, it builds up, you got your vehicle on fire, the tractor burns down. That's what I want.
And then you've got the awkward phone call.
Yeah, but that's maybe the one of.
Yeah, that's the extreme.
It doesn't
the
mean,
extreme situation.
It doesn't mean you got a cool EGR, it burns down, but
yeah,
it's just easier to clean.
Yeah.
The next one is, if you got the exhaust getting through your cooler, you got the sulfur which condense, and then it sits on the cooler, on the surface. It sits in the valve, and with the time, that sulfur eats up the metal.
Yeah.
And then you need a different cooler, or new valves. It takes time.
Yeah.
But it's out of warranty. Somewhere in time, you need to do this. So either you cope with it when you're still the owner, and if you resell it, I don't know how it's in the market today, but I assume the resale value of a cool EGR might be lower because you have more to repair.
The potential problems that might come with it. Yeah.
So the other thing is, obviously you have more piping and tubing in the installation, so it makes it a bit harder to install. The fan, by the way, you need a little bit more power for the fan because you need to get more air blown through the cooler. Okay. To cool down the exhaust.
So it's a bit of a balancing act, you could say.
Yeah. Well, you know, see, this is additional fuel burnt just for this. Yeah, this is when you compare fuel maps. You don't see that, but at the installed machine, that's what you reckon. Yeah. And you miss some power always in the field because it's just at the fan. Yeah.
But you could say the same for any component on this engine. Any of the ancillaries, they all take a little bit of power, and it's like you say, it's just a bit of a balancing act, isn't it? Trade-offs, lots of compromise.
Yeah, I mean, one of the things is, as we have no cool EGR, you need a little bit more AdBlue, obviously, because you got more NOx getting out into the after treatment. But the overall advantage is you have less fuel you burn. Yeah. So as long as you pay less and your TCO works out fine, that's perfect.
That's it. Yeah. So basically, you guys let the engine be an engine, let it do its thing, and we'll sort out the exhaust afterwards.
I like that you say that, because this is pretty much what I say. Yeah. I mean, exactly. The more you let the engine perform, the more you give the engineers room to have getting more performance out of the engine, more power, fuel saving, transient response time it's called. So transient response time, the engine reacts quick, it's agile. Yeah. And then anything else gets dealt with at the after treatment.
Yeah. And in terms of that after treatment, I assume it's DOC, DPF, SCR. Is it all those, is it?
Exactly.
Yeah. Good stuff. So, going back to where this engine may end up in the agricultural market.
In tractors.
In tractors. You've got a customer for this.
Yeah.
It's coming, is it?
Yeah.
Yeah. But we can't say yet.
No.
Not yet. No. But it is coming. So
it is coming. It's definitely coming. Yeah. I can 2025.
2025.
So let's say 2025, it will be there for production. Yeah. We got prototype units out there that get tested. and test results are great. So yeah.
Cool. I can't wait. I'm looking forward to this. So there you go, ladies and gents. 2025, Cummins back in mainstream tractors. Because obviously we can't ignore you are quite a big player back in agriculture already. You know, we've seen you in AgriFact, we've seen you in the Versatiles. JCB are a big customer of you guys. So you are there.
Hey, wait a minute, didn't you see us in the Trion?
In the Trion, of course, in the Trion, and we're going to chat about the L9 engine in a little bit as well. So
exactly.
You are there. Would it be fair to say you guys, Cummins, is on a resurgence back into agriculture?
I would think so. Yeah, you can say this. I mean, you know, yeah, there's no doubt. I mean, you see more presence now.
Yeah.
And you see the presence with the quality brands. So let's say Class, AgriFact, take it on.
Yeah.
So yeah, others definitely.
Excellent. Well, Jürgen, thank you very much for your time.
Thank you. It was a
It's been
pleasure.
an absolutely fascinating insight. We'll have to catch up again some other time because Jürgen has got some fascinating stories about Cummins history, which we're having a chat about over a coffee just before. So maybe one day we'll do that as well.
Yeah.
But for now, thank you very much for talking us through structural engine projects. Can't wait to see this in a mainstream tractor.
Yeah.
2025, folks. That's not the end of our chats on the Cummins stand. We've got more for you coming up very shortly. I think we're going to be talking hydrogen projects, L9, maybe a little bit of battery chat as well. So stick around.
We've just seen the latest in diesel engine technology and development. We're now going to move on to an alternative in engine development which Cummins is working on, specifically the design philosophy behind the hydrogen engine. Now, to help me understand this, I've got Jonathan Miller. Jonathan, explain to me what this is all about.
Absolutely, yeah. So, as we all know at the moment, I think at the show, the buzz has been around Cummins' brand new development in hydrogen.
Right.
Where obviously we've been working on this product now since about 2021. That was when the development started.
Okay.
As we can see here, the block is coloured in two different colours. This signifies our commitment to having a really flexible integration with the red part at the bottom here that's available and easy for customers to continue to use across different fuel types.
Okay. Understood.
But I think one of the main questions we're getting today is how do we maintain the capability to operate on different fuels while still making it easy for the customer to integrate into their products? And this is all happening in the white section at the top here. So the cylinder head, the fuel system, the air handling.
Now, so the engine at the bottom, the red bit then,
Absolutely.
that's an existing engine block.
The carcass, yes,
It
for
is.
sure.
So we make this, is this a 6.7 engine, is that what it is?
This one is a 6.7,
So
yes.
we've got your standard, I know it's not quite standard, but your standard block. We can change the pistons, we can change all that sort of stuff in there. The bit that really is the game changer, if I'm understanding you correctly, is this, the white bit, which is the cylinder head development, and I assume the injection system and everything else that goes on it. So how have you come to this? How has Cummins approached this?
So this is the output of many hours of our expertise and testing and development.
Okay.
And when we look at this and we look at the platform moving forward in a fuel agnostic space, we're able to leverage the same block as you mentioned while changing the componentry and capability of the white section top.
Right.
That allows us to run on diesel. It also allows us to run on natural gas, and it also allows us to run on hydrogen.
Right. And it's the cylinder head that's a key component.
Absolutely, yes.
So this is a hydrogen cylinder head.
This one, in this particular configuration, yes, that's correct.
So tell me, I know, for example, having sort of done a bit of research and covered this a little bit before, hydrogen is a pain in the neck because it moves really quickly, and if you don't do something with it, it disappears.
Very true, very true.
So what does this head do that perhaps the diesel head, so it makes it understandable?
Yeah, there's some different design philosophy inside, particularly some of the valve arrangements.
Okay.
And that allows us to control and combust the gas in the right way. And that largely allows us to obtain very similar levels of power that we can obtain with the diesel and gas solution, which for a product like this operating on hydrogen that's so new in the marketplace, the effective engineering behind it and the efficiency we've kept between the different fuels is really something we're very proud of.
Well, that's very good. So, hydrogen engine, I assume with the valve arrangements and stuff like that, you have to keep the hydrogen moving so that it's swirling. Is that the idea? So as it comes in, get it in there, burn it quickly.
Very true. Yeah. So the injection system, as with the difference in the head, has been updated to be capable for hydrogen, as you mentioned. And how we combust the gas in comparison to diesel and natural gas is different as well. Yes. Yes.
Yeah. So this, like a natural gas, is your spark ignition, right?
This is spark ignition, yes.
So you're using basically the same technology as you would for a petrol or a gasoline engine if you're the other side of the pond.
I think you can draw some similarities, yes.
Yeah. So it's very similar, but obviously adjusted for the timings of spark and everything else.
No, that's the secret sauce, right?
Yeah, you know. So another issue, exactly. Yeah, we're treading on dangerous ground here, folks. Secrets. Another thing that it always intrigues me with hydrogen, how has Cummins addressed the fact that one of the problems we know with hydrogen is it's extremely difficult to store it because of being able to keep it under pressure before you can get it into the machine. So how are you dealing with the problem of storing hydrogen, because that is very difficult, isn't it?
Yeah, so safety is obviously paramount with these products, and as we're working with customers during our application engineering processes in order to help the customer make the product as safe as possible and reliable as possible, to complement that process, we've also got a range now of MPROX tanks, which we can see on the wall back here as part of our hydrogen ecosystem.
Right.
These tanks are specific and capable in order to be integrated into the vehicles. And this really gives us such a capability in order to make our customers successful, and while addressing the relevant safety concerns that should be in everyone's mind when you're dealing with hydrogen.
So you've got these tanks that can be integrated into a vehicle design, and one of the problems we've seen before with other manufacturers who are dabbling in this, and there's a lot of people who are, as you know, it's not like it's a new idea, is that it's been able to get enough fuel in those tanks to keep an engine running for a working day. Is that something that you're doing? Is that a bridge that you've managed to cross? Or?
Yeah, we've definitely considered it as how we integrate the product, for sure. And I think as customers will notice when they're looking at putting these tanks on the system, it is different to what you would expect with a diesel fuel system.
Yeah, very much.
Very much so. And I think that our efficiency and ability to store with these MPROX solution really puts us in a good position to give the right solution to the customer with the right space claim while making it efficient delivery to the engine.
Now, another question I've got for you. So we know, again, Cummins is one of several manufacturers that is doing this. Is an engine like this specific to a market? So, we've seen ethanol engines, we see compressed natural gas engines, we see all these different types, which, we've got a diesel engine bottom, and then we say, right, we're going to make it. Is it something that's becoming market specific? Where we've got hydrogen available, we'll do it. If we've got ethanol available, we'll do it.
That's such a great question. At this point in time, Cummins very well, like you've said. We offer a range of products for a range of different markets, and when we work with our customers, we often consider their requirements in our process as we build a specification particular to them. At this point in time, this particular engine is, we're looking at the industrial markets, but we're also looking at on-highway as well. So the existing markets that we serve are definitely the target for this type of product moving forward.
Okay. So we've established what's going on with Cummins in terms of this. Now there is another little avenue that we need to walk down, because there is the electricity avenue, isn't there?
Absolutely. So another great set of questions.
Another minefield here in the world of alternative fuels. Tell us a little bit about Cummins' involvement in that specific market sector.
Yeah, I think you touched on it earlier on when we were talking about this product in terms of design philosophy. Mm-hmm. Well, in the customer space and the decision that you have to make and appropriateness of the type of fuel or the type of technology you're implementing in the marketplace is paramount when you're thinking about a sustainability strategy.
Yep.
So many customers are looking for the requirements and the need from Cummins and other companies like ourselves to provide more than just an engine solution in some places. Now the market moves in different places at different speeds, and the different types of technology
Right.
often demand different solutions. And that sort of really puts us in a position where Cummins recognised that quite a while ago, and we've recently launched our Accelera brand, which is Accelera by Cummins.
Right.
And that sort of really brings into focus just our commitment to provide many different power solutions across a range of products that is not just an internal combustion engine. However, the internal combustion engine isn't leaving the marketplace, and there's no intention
I don't think
of
so
that.
either.
But we do recognise the need to be able to be flexible and support our customers with whatever challenge is in front of them.
So now I've got the $1 million question. I think it's $1 million question. It might be about $500,000. But so when are we likely to see this type of engine realistically appearing in various, whether it's an industrial or non-industrial or off-road? When are we like to see these engines appearing in applications that are usable?
So I think in terms of introduction to the market, it depends on customer uptake of this type of technology.
Right.
Customer uptake of the type of technology could be based on a number of factors. Is it the right solution for them? Do they have availability of the fuel?
Yeah, the
And these are
product.
normally the types of questions we're getting today is, okay, we have a product, but can I obtain the fuel? And I think that solution, that is being dealt with, especially in the UK, by infrastructure bills and the sort of the rise of hydrogen generation.
Right, yeah.
I think that's it's an exciting time to be around in that space, and I think that these types of products could be visible in applications around about sort of the times that we may see shifts in regulations.
Right,
And I think that's sort of around the 28 to 2030 timeframe. I definitely think that before the end of the decade, we'll be seeing much more of these things
appearing in regular in commercial use.
I believe so.
Yeah.
I believe so.
So essentially, what we're dealing with again is we're dealing with legislation, like we've been dealing with diesel engine emissions for God knows how long. It's going to steer us towards having this type of an engine, and obviously with the infrastructure, we need the infrastructure in place to do it.
Yeah, and I think it's not necessarily the regulation driving it, but it certainly does help people come to a natural conclusion of making a choice between what their future looks like. And again, just to point back to the engine piece, that's why we have this flexible product. If you integrate diesel today with a change in the product architecture here, that means that you can access a new fuel type with minimal impact to your application design.
Yeah, and minimal cost, minimal, it makes it making it affordable for the end user
Absolutely,
as well.
and customers are the beating heart of our organisation as well as our people. And really, as we've gone through design philosophy for this, we've put that front and centre in our minds as we think about how the product can evolve in the applications that we serve today.
Well, if that isn't a useful insight into what's happening in the world of the internal combustion engine, then I don't know what is. So I'd like to thank you very much for that. It was really good. I've learned a lot too. I've learned a lot of stuff today. Thank you very much. And come on, we've got more to do yet.
So, ladies and gents, we move on the Cummins stand, in my Nirvana, basically. And once again, we're joined by Jürgen, who's going to talk us through the L9 engine and sort of its development, and again why it sort of came to fruition. So Jürgen, just talk us through the L9.
Yeah, the L9 is an engine we have in our portfolio for quite a while. The previous engine was an 8.3 liter engine. We increased bore and stroke to an L9. Oh, don't ask me when it was, but definitely before stage 3A, because we had the L9 as a stage 3 engine already.
Okay.
We developed it further, Tier 4 interim, Tier 4 final. Well, for Europe context, it was stage 3A, stage 3B, stage 4.
Right.
And finally, we got it as a stage 5 engine.
Right.
No?
So it has seen quite a lot of development, this engine.
Yep. Yeah. It's around for a while. It's a proven engine.
Yeah.
And yeah, that's how the L9 is here.
And was it developed for any particular industry or application to start with?
Yeah, what we typically do is we have an on-highway division for on-highway vehicles, trucks, and the off-highway division for construction and agriculture.
Yeah.
So why it's worthwhile to mention we have those two divisions: own management, own decision-making process, own engineering department. So what on-highway started for the trucks in the high-volume market, we from the off-highway could take it and make it a fit-for-function off-highway construction engine, agriculture engine. So it works perfectly also in applications.
Yeah.
Not be smoothly sitting on a truck and driving along
Just
the
nice
on-highway,
and constant.
just doing the dirty job.
Yeah. And what are the challenges when it comes to developing an engine like this for the different industries? Because like you say, duty cycles, the different loads on the engine, it's going to vary a heck of a lot from job to job.
Yeah, of course. No? So in the off-highway, you have a whole variety of applications. Now you have excavators, wheel loaders, you've got pavers, you've got drills. So a lot of it is about, again, a good amount of torque, so the engine doesn't stall. The peak torque goes a bit more towards the lower speed.
Yeah.
And then I think, again, transient response time, that the engine is agile and recover quickly from sudden load which may get applied.
Yeah.
Yeah, yesterday we talked about a little bit like how tough are different environments. That agriculture is a hard environment, and we were like, well, so what's harder, mining or agriculture? So it's very similar. Now. In mining, you have those drills. As an example, drilling a hole, you get through the mud, through the soil, and then you hit a stone.
Yeah.
And
big load,
exact,
big shock
big
load.
load immediately, bang, And the engine needs to react immediately, throw in enough fuel.
Yeah.
So that's the transient response time to recover.
Yeah.
So it doesn't stall. So now imagine that engine would stall. The drill is like 6 meters down in the ground.
Yeah.
You won't get the drill out.
That's the last thing you want,
You have to dig it out. So how would that translate in agriculture? Yeah, you have a combine with kind of uneven field. You have wet spots, so the load could suddenly increase, and the engine has to respond. So that's a bit what the engine is geared towards anyway.
Well, that's it. And you mentioned combines there.
Yeah.
Obviously, we've seen already. I mean, we just mentioned it just a little bit before. This is in the class Trion combine. So how did that sort of partnership happen?
Yeah, that was an interesting one. I mean, we started also, I would think, 2013, talking about joint projects. What could we do? Looked at different products. Obviously, Class builds globally machines. We build globally engines. And what was at the time a perfect fit was actually the 6.7 and the 9 liter.
Okay.
For the future product Trion.
Yeah.
And it took us a while and really looking at the details of the engines. It was a perfect fit also from the power offer. Let me think, from 190 kilowatt to 320 kilowatt. So the 190, obviously, that engine is too large for this. Call it a little brother. The 6.7 is also in the Trion. So we have actually two different engines in there, the 6.7 and the 9 liter.
So it's 6.7 the smaller ones, and obviously it's the L9 for the bigger ones.
Exactly. And also what is interesting about this engine, what it says here, it says harvest engine. So what we have done is, by understanding the requirements of Class, well, not of Class, but of the combine, we reckon, we need to do a little bit more change a bit more the torque shape. And with this, we also came with better fuel consumption. And this is how we launched this L9 for the Tryon. What else is unique to this? Well, it's not unique. It's like always with our products. No cooled EGR.
Yeah.
Exhaustively talked about that on the tractor.
I was going to say we've done that one.
So I could repeat the same, but just cut it over and put it in here. And what else to say? The other thing is, when you look at this little tiny cylinder here, that's the after treatment.
That's it. It's all in that canister just there.
Yeah. And it's installed very well on the Tryon. I mean, whenever you're allowed to do so, get up to the Tryon, have a look at the engine compartment. It feels great, you know. You just walk in there, you got the access to the engine. The after treatment sits here.
Yeah, I remember from the class at an event at Saxham in the UK with the Tryons.
Yeah.
And they opened it up, obviously in the engine bay. And like you say, it's a very modular layout. It's engine there, after treatment there. So from a service side, obviously, you must put quite a lot of thought into that to make it as easy as possible.
Exactly. No, so all the service side is here because you can't access the engine on that side. So everything is accessible here. I have to mention it. No cool EGR. So
just get that point home. Drive it home.
Yeah. Well, what can I say? It's easier to access, you know.
Yeah.
And as the after treatment is small, sitting here on the side, you just walk in there. You have space to do your maintenance work.
Yeah.
Perfect. And that was also the feedback we were getting. Yeah, when we launched the Tryon, it was pretty much appreciated by the dealership at the time.
Really?
You know? Yeah, they were like, oh, that's good. Easy access. Yeah.
Good stuff. So this L9, obviously you got it in the Class Tryon combines.
Yep.
Do AgriTech use this as well, do they, in their biggest sprayers?
Yeah,
the Condors?
They use that in the biggest sprayers, and they use also the 6.7.
That's right,
in the smaller sprayers,
yeah. That's another one for you folks. If you've not seen that one, go check out one of our customer reviews about an AgriTech Condor Vanguard, which has got 6.7 in there.
Yeah.
Apparently it's a climber. It's a climber, it will go anywhere.
It is, yeah.
Excellent. Well, Jürgen, I mean, thank you again.
Thank you very much.
Thank you very much once again.
So, an interesting development in engine technology which has been showcased here at AGRITECHNICA 2023 for the first time is a development in valve train technology which has been pioneered by Jacobs. Now, Jacobs is a famous company that's part of the Cummins group, and here to explain to me a little bit more about this new development is Mr. Hilko Schmidt. Hilko, thank you for talking to us.
Very nice. Nice to meet you.
Nice to meet you. Can you tell us a little about what we've got over here?
Yes, absolutely. Yeah. What we're looking at here is the first time that the combination of an engine brake, well known already in the industry, and the HLA, the hydraulic lash adjusting system, is made possible. Previously, when an engine had the HLAs for good reasons, so you don't need to set lash anymore on your valve train, you don't need to open up the engine cover for that matter, and therefore you eliminate any risk of intrusion of dust and dirt while you have to do that. If you had that HLA system, if you would have an engine brake, they would actually counteract to each other. If the engine brake would be active, the HLA would extend to a certain extent that you would have a catastrophic failure risk.
So okay, now I was wondering why that was never done. So now I understand why we're doing that. So explain how it works then.
So what we have developed is a system that prevents the HLA from shooting out when the engine brake is activated. So a very simple on paper, and if you look at it, it doesn't look very complicated, but it's a very finely tuned and finely designed element that prevents the HLA from jacking out. Therefore, the combination of engine braking functionality and an HLA is now possible for engines that have that technology on board. It's very much applicable to this show, where there's off-highway, of course, involved. There's very constrained engine packaging, after-treatment systems are very often completely mounted on top of the engine. So access to the engine and the avoidance of any dirt intrusion is very key, also going into the future.
So this is essentially providing a foolproof, robust version of allowing you to have an engine brake essentially on an engine where you wouldn't normally be able to have an engine brake in an environment where service accessibility is very limited.
Very limited, and when it's limited, it's costly because you spend a lot of time on downtime of your truck if you have to do so.
Now,
that combination is very, very key.
The Jake brake, of course, is famously associated with the Cummins engine, and obviously with Jacobs. Jake brake applications, we don't tend to see so many vehicles with Jake brakes these days. Is it because of the hydraulic lifter technology? Is that why they've stopped using them? I mean, give us an answer.
On the on-highway industry, the Jake brake or an engine brake technology, a compression release engine brake, is commonplace. So you find that everywhere on a on-highway truck going from Amsterdam to Torino, for example. In the off-highway segment, previously it was just not possible. Therefore, it was never there.
Right.
But there is a need. You know, you got tractors and applications that are going downhill, need full vehicle downhill control.
Yes.
Where the engine brake is going to help a lot.
And to prevent wear on the brakes and the and that's on tyres on faster tractors. So I completely understand that.
Yep. And also going into the future, when you're talking about stricter emission regulations, your valve lash is very important to keep as constant as possible, so you have a predictable emission outcome. So seeing HLAs in a valve train for an off-high application is going to be more and more the case. And now with the engine brake being compatible with that technology is going to be a plus for everybody.
So this has obviously been developed. It's not in use at the moment, is it? But it's been developed for a Cummins engine. Now, is this on a technology that you can apply can sell to other manufacturers?
Yes.
So you can go to competitive, say, well, I'm assuming this is a patented technology.
Yes.
So this is sort of thing that you can actually, other manufacturers can come to you and say, I want this.
Exactly. And that's how we are structured within Cummins as well. We are part of the Cummins Engine Component Group, which does business with Cummins, but also a lot of business outside of Cummins. So this is typically technology that we are selling outside of the Cummins Group as well, for any OEM, for any engine manufacturer that can make use of this technology.
Really? That's incredible. So you've seen it here first. We've actually got the opportunity in the future to have Jake brakes on tractors. I can't wait.
I was just going to say, I can't wait for the sound. I can't wait for the sound of a Jake brake going downhill.
Hilke, thank you very much, sir. It's been very, very intriguing. A nice surprise. I didn't even know that was here. But again, AGRITECHNICA, what an amazing place.